Hi everyone, today we'll learn about fractional indices. We just completed negative indices. So we'll continue with this. This is the topic we're dealing with today, fractional indices. We've completed basics and I've put in all these rules that we have used for the same. And then we'll complete the fractional indices today. Now, fractional indices are interesting. What we've learned till now from a natural number perspective, or maybe an integer perspective, that you could use negative indices, you could have positive indices, and you could have indices 0, right? Now fractional is important because you could have fractional indices as well, and they are very important to understand the way indices work. So let's say we all can understand all this. What is this, right? 5 to the power 2 is 5 squared is 25, but it is not as simple if someone has to tell us, because this is used in normal mathematics in simple mathematical terms as 25. We have also learned that something to the power of 0 is equal to 1. We have also learned that something to the power minus 2 is equal to 1 by 25. So these are all integers, right? Positive, 0, negative, full integers. What we want to now see is what happens if your power is fractional in nature. So it's 5 to the power 1 by 2, right? Or let's say 5 to the power 3 by 4. So it's not 1. Okay. And it is less than 1, or it could be more than 1, but so 5 to the power 7 by 2. How do we deal with these fractional indices when we have them? Okay, so the basic process is we treat them as two parts. So 5 to the power or 8 to the power, okay, let me use the numbers first and then we'll use the general notation like that so that it's easier to understand. So 5 to the power 3 by 4 will be used as, we will use this as, can we use this as 5 to the power 3 and then 1 by 4? This is 5 to the power 3, we can calculate 125, right? And this is 1 by 4. Okay, and when we say 1 by 4, is essentially means it is something that you have to take to the fourth root of. Okay, so we can write this as something like 125 to the power 1 remains 125. You can write this as this is known as the third notation, fourth root. You can put 4 there, which means this is fourth root of 125. We'll learn about this a bit more, but essentially what we're saying is if you have a to the power, let's say p by q, this can be written as a to the power p, which is the numerator, right, to the cube root, right? This is how we simplify this. The numerator can be used as a standard index and the denominator is that value of the power. Let's use some easier and a bit more complex usage of these. So let's say if I have what should I say? Let's say if I have 5 to the power 3 by 2, right? Fraction. What do you do? 5 to the power 3 and then you do square root of this. So this is basically square root of 125. It stays there because we can't directly calculate the value of the square root of 125 because it's not a perfect square, 125 is, but that's how you progress on that. So let's say we had something like 8 to the power 2 by 3. Okay, we use the same notations. So we use 8 to the power 2, and this is the cube root. Okay, either we leave this as a sub notation, we can leave it that way, or we see if we can simplify it further. I think we can simplify this further. So 8 to the power 2 is, you can write 64, right? And this is the cube root of 64. Cube root of 64 is something, for things to be simplified a bit more, we need to do what we call the factorize this. Now, if we start breaking this and try to use the lowest base for this, we can write this as cube root of 2 to the power 6. Can be cube root of 2 to the power 6. So 2 to the power 6, and then I'm using this formula back, and this is 1 by 3. Because this is the third root, it comes as 1 by 3. Remember, if we use this notation now, they get multiplied. So 2 to the power 6 times 1 by 3, this gets cancelled, to the power 2. This is 4. Now see, we could have done it slightly differently as well, and we'll show how we could have done it. We'll see what is an alternative method of solving this. Eight to the power 2 by 3, right? We can expand it to say, what is 8? 8 is 2 to the 2 cube, and this remains as it is. We haven't changed that. Because we can factorize 8 into 2 cube, now we have used it as an index notation. Now you can see why. Primarily because I can now multiply these things, get 3 and 3 cancel, and simplify it further here, right? So 2 to the power of this 3 gets, because we can use this identity now, that anything when you have an index to one power of index, you can multiply the indexes. So 2 to the power 3 and to the power of 2 by 3, you can multiply these indices. You get these 2 get cancelled out, you get 2 to the power 2, which is equal to 4. This is an alternative way of getting to the same answer. But what we have done essentially is we have been able to factorize it. The advantage of this question was we were able to factorize it. In this case, we were not able to factorize it, and hence we had to leave it that way. Okay. So this is an example of a fractional index. We will take one example that brings negative index and fractional index together. Okay. So let's say you have something like 16 to the power 7 minus 7 by 4. Okay, we can use this process because 16 we know can be factorized as a power of 2, and let's see whether it is useful. 2 to the power 4 is 16 minus 7 by 4. Now you can see it, I'm sure you can see it, that this 4 and this 4 gets cancelled out. So when we get there, when we move ahead, you get 2 to the power 4 gets cancelled out with 4, you get minus 7, 2 to the power of minus 7, and we use the rule of negative indices, that one, to call it 1 by 2 to the power 7. You can either leave it here or you can calculate the value as 128. Is it? Yeah. So that's your answer here. Right? That was the basics of negative and fractional indices and how we use them together. We'll do some problems in the next session.